This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better. I'm Jessica Morrison.
And I'm David Blaney. Today we're investigating research into dementia. From memory loss to speaking difficulties, the symptoms of dementia, and in particular its most common form, Alzheimer's disease, are well established. But despite the first cases of dementia being documented more than 100 years ago, medical scientists have yet to determine how to prevent it. To discuss the future of this topic further, with us today is Professor John Mamo, the Director of the Curtin Health Innovation Research Institute. Thanks for joining us, John.
Oh, my pleasure.
John, are we ever going to discover a cure for dementia?
Look, I think that's a pretty substantive kind of claim, which when I hear every now and again does concern me. You've got to appreciate that dementia really describes a phenotype, a set of symptoms, and in that it's an indication that the disease has multiple origins in terms of why it's developed, and that could vary tremendously from one individual to the next. It's a little bit like saying, will you find a cure for cancer? And there's many types of cancer. So there's certainly forms of dementia where I think we can, with our greater understanding around risk factors, can take steps to certainly prevent or at least delay the onset of the disease. And there's certain forms of dementia where, with appropriate interventions, you might be able to slow the progression of the disease. Having said that, there's nothing that I think is on the immediate horizon which will say, look, we've got a promising pharmacotherapy or drug which will essentially stop cognitive decline in people who have already showing signs of significant memory loss. You've got to appreciate that when cognitive deficits begin to appear in individuals, it's normally after decades of very subtle disturbances that have been occurring in the brain, and there's probably quite reasonable damage that's occurred by that time that we see those recognisable symptoms. Extraordinarily, the brain has tremendous mechanisms for compensation, so you can have regions of the brain which might be affected through a disease process of some sort. And there's other parts of the brain which can essentially carry you and provide you with mechanisms to continue to perform at fairly high function. But to have a frank cure for dementia is really, I think, probably a little bit aspirational than being realistic.
Before we can understand the future of memory loss, essentially, do we have any idea about what causes dementia and its most common form, Alzheimer's disease?
Okay, so dementia normally is a phenotype or a behavioural disturbance which reflects substantial loss of brain cells. That's what's actually happened. The reason why you've lost brain cells could be for a variety of different reasons, and I might just touch on some of those. So dementia broadly describes a class of symptoms that one has, and clinically they tend to sort of pseudo-cluster dementia into two forms. One of them which they say has an origin coming from blood vessel disturbances, so that's vascular-based dementia, and you'd probably say about 20 to 30% of people who get dementia will have a vascular-based association for that indication of that disease. Alzheimer's disease is clinically identified as the major form of dementia, but what Alzheimer's disease really describes is a very classical set of pathological features which occur in the brain, and some of your audience may have heard of deposits of protein which form in the brain, or senile plaque, and these are protein deposits, things that should be in solution which have come out of solution, which tend to stress the brain cells, and over a period of time can actually kill those. And for probably 30 if not 40 years, a lot of focus has been on terms of what's causing these protein aggregates to cause death of brain cells over a period of time. And as things happen, and we go around a little bit in circles sometimes, it appears that some of that propensity to form these protein aggregates might be because of disturbances in the way the blood vessels are functioning in the brain. So we've come full circle to say that Alzheimer's disease may also be a vascular-based disorder, but it just happens to feature these particular aggregates of material that form in the brain. Then there's other conditions which could lend themselves to loss of brain cells, and by extension to dementia. People who have stroke, if certain regions of the brain are starved of oxygen and of nutrients for a period of time, those cells can basically die off, and you can get a stroke-associated dementia phenotype. People who have other types of neurological or neurodegenerative conditions may be at higher risk. So people who have Parkinson's disease or people who have multiple sclerosis, there's other forms of damage which are occurring in there which can also lead to loss of brain cells. So there's a whole myriad of risk factors which can contribute to that process. And then there's environmental risk factors, and importantly, what's your genetic ability to handle those environmental risk factors. So, we know about smoking and the toxins associated with that, equally other environmental pollutants that you might inhale. So certain people in certain industries who have had lifelong exposures might be at risk of neurodegenerative diseases, which can manifest as a loss of cognitive performance and memory considerations. So lots of reasons for it, and then the way to consider prevention and treatment would be to identify what's in an individual, what's been the pathway which has led them to the development of that disease and what's available to us. People say that the biggest risk factor is age, and in part that's true. We've got in both developed and developing nations, we essentially have a population which is getting older, which means that the challenges that the brain has, including the vessels which support its function, the blood vessels which host brain function, there's a greater risk that they will become compromised over a period of one's life. And then with that will come the slow deterioration of brain cells. So, yeah, it's a broad spectrum disease.
In 2009, you discovered a link between saturated fats and Alzheimer's. What's the link?
Okay, so the brain's a very interesting organ. It utilises glucose essentially as its obligatory and almost exclusive energy nutrient, and it has an exceedingly high demand for glucose. So high, in fact, that it basically utilises about 20% of heart blood volume. So in the course of a day, your brain would receive about 1,000 litres of blood, and at any one point in time, as the blood is passing through the brain will extract about 50% of the glucose that's in there. So it's got this insatiable appetite for energy, and you can think why. The brain controls every component of your body, from your respiration to your walking to your thinking to your visual order and processing, absolutely everything.
Things we don't even know are going on in the background.
Yeah, I've seen calculations where if you were able to have someone to sit and think of nothing and do nothing for 24 hours, the amount of glucose they would utilise by the brain, it works out in the order of kilos. I think it's about 1.5 to 2 kilos per day. Manufactured by the body, I might say. It's not that you're consuming that amount of glucose. And just by comparison, if you were to do a half marathon, the city to surf, and look at the exercising muscles in your legs and how much glucose they would have used, and it would have been about 500 grams over that period of time. So there you are, a hypothetical someone thinking about nothing, and they're using huge amounts. So here's this organ that has to have tremendous amounts of glucose being delivered in an efficient manner. Now, how does the brain get access to that? And it's constructed a microscopic blood vessel network which is unparalleled. These microscopic vessels are called capillaries, and in a human brain, if you were to open every single one of those capillaries, you're looking at a surface area of around 30 square metres. So that's a good sized bedroom or something, 6 by 5 metre bedroom. So the blood's spread over these capillary networks, and there's the brain cells, and they're just sucking up this glucose at the rate of knots as is required. Now, the old textbooks, medical textbooks that is, they would describe that the architecture of these brain capillaries is such that they are highly exclusive. They will protect the brain, and they will only allow certain things to go in, namely glucose and oxygen, to burn off the glucose, and they'll prevent everything else. And to a large extent that's true, and you want them to be like that, otherwise we'd be prone to getting brain infections, and then we wouldn't be living very long. So these vessels are generally pretty robust. However, the studies that we particularly focused on, and this is where the question stemmed from, was that is there components of our genetics or things that we do in our lifestyle behaviour which modulate the functionality of these microscopic capillary vessels? And the answer is yes. Things that we consume in diet, including saturated fatty acids or saturated fats and alcohol, and amongst other factors, can regulate how these blood vessels, these capillary vessels, behave. And what we found is that if This is in preclinical animal model studies because we have to sample brain tissue, which we can't do in living human subjects. In those animal models, if you give them a diet which kind of resembles what Westerners would eat, modestly enriched in saturated fatty acids, it's not a really harsh diet. They're not getting, really high blood levels of cholesterol or anything like that.
It's not great either, though.
No, it's not great, but it's something that many Western people are consuming on a daily basis. So one which is not causing, a massive increase in, your bad cholesterol and blood. We find that in those animal models that those capillary vessels misbehave. And essentially what happens is they leak. And with this leakage, you get small movement of things that are in blood going into brain, which is not meant to be happening. And with that leakage, you get what we call silent inflammation. So you can't feel it, you don't have a headache, you just have this slow stress phenomenon occurring on these microscopic vessels. And if you maintain that dietary behaviour, we find in the animal models that the vessels get worse, and the brain cells that immediately are supplied by those vessels, they don't remain so nice and healthy. It was a really interesting realisation, and we found that if we gave mice fat-enriched diets, but instead of putting saturated fats, we put in what we call liquid oils, monounsaturated oils, things that you'd find like in olive oil, or there's a lot of interest around fish oils, we would find that those types of oils didn't have that damaging effect on brain capillaries. And that early finding really came home to us because it made us recognise that there's many things that we might be doing in our ordinary behavioural activities that over the course of one's life can influence the integrity of these capillary vessels and by extension risk for a whole range of neurodegenerative diseases. So I've got a very large group. I'm very blessed. I've got some fantastic research people in my group. But the whole premise of our studies is that what is it about our living environment and what we breathe, what we eat, what we drink, what we smell, what is it that might be modulating capillary vessels, making them unhealthy, or alternatively, making them healthy? And we identified some interventions which may confer protection to brain capillaries. Essentially, we were looking for things which would dampen inflammation of those vessels. Now, that doesn't mean you can just take an anti-inflammatory and it's going to be the panacea for everything. You've got to identify what are the major insults, what can we do to prevent those insults, and is there opportunities to restore function? That's where we won an award for. So we might say, look, we know that smoking's bad, we know that drinking alcohol is probably going to be bad, saturated fatty acids is probably bad, pretty much anything that protects the heart's probably going to be good for the brain. Yes. But what worries me is around awareness and responsibility in the sense that I often hear people say, look, it might be a good time of year, might be Christmas time, so they're going to misbehave with their diet. And I say, look, it was a weekend of binge, poor eating, whatever it might be, but now I'm back onto it. I'm really protecting myself, really doing everything right. And my analogy is this. If you've got a wound on your hand somewhere, and, you've irritated that wound, you would take some steps to treat it. You would put on some topical ointment or whatever it might be, and so be it. But my question would be, would you go and scratch that wound and then go and treat it again? Because the microscopic vessels of the brain are far more sensitive than the surface of your skin on your hand. You wouldn't pick at the wound on your hand. Why would you insult the microscopic vessels of the brain? It doesn't work to say, well, I'm going to do this poor behaviour, knowing full well that it's challenging the brain capillaries, and then say I'm going to behave the next day. I think the risk that we have as individuals for developing a neurodegenerative condition, we're talking about dementia today, is going to be an indication of what has been your lifelong exposure. What have you done over the decades of your life, and what's your genetic ability to handle those things that you've done? So my very strong advice to your audience would be that every insult hurts. Every single insult hurts. So you eat as well as you can, you avoid alcohol if you possibly can, you do all the things that we know are vascular protective if you have a real invested interest in wanting to prevent this disease.
Do you think that that's the main thing looking forward, that there really isn't enough awareness?
Yeah, most certainly. I think education is part of that answer. When you think about it, people on the street would have a reasonable understanding of, what cancer is. And, it's the proliferation of cells in different places. And what can we do? Well, we can do chemotherapy, and that will target the cancer cells, hopefully. So people have an awareness. But when you ask people, well, what do you know about the brain? What sustains the brain? What can you do in terms of maintaining healthy brain function? The awareness factor is really quite limited.
Somewhat ironic because they're using their brain to answer that question.
Absolutely. So there is a role around education, and I've often toyed with the phrase, being bloody-minded, or writing a book about being bloody-minded, because it's exactly that. I think the origins of brain health are around maintaining vascular integrity to support that organ structure. So we want those vessels to behave really, really well. So part of it is around that, education.
In terms of research, what else is happening at Curtin's Health Innovation Research Institute around these topics?
Well, we've got people who are doing research which is directly related to Alzheimer's disease, and we have people who are doing studies which are indirectly important in terms of what we're considering. So we've got some groups of scientists who are looking at what's the basis for those protein plaque that are forming in brain, and what can we do to regulate that. So that's being done by a group which is led by Giuseppe Vidale, and they're doing some fantastic work there. We have people who are looking at metabolic conditions where there is a very high risk of developing cognitive deficits. So people who have diabetes are at much higher risk. The reasons for that aren't completely understood. We think we know why. We've got some very exciting lines of research which are related in terms of what might be causing capillary damage in people who develop diabetes. So that's a really important consideration, because we have a lot of people in developed nations where energy availability is all too much. That's highly relevant, and we think there's some exciting therapeutic opportunities there. We've got a very exciting line of research where we've identified a historic drug which was once used to treat cardiovascular disease. It's about 30 or 40 years old now. And this is a drug which is particularly interesting because it focuses on both the aggregation properties of that protein, it focuses on the vascular integrity of the capillary vessels, which we're really interested in. And this particular drug also has a very unusual third property, which is around very potent inhibition of oxidative processes. And often at the heart of many diseases, when the cells are in the process of essentially cell death, that's going through a process which involves the production of compounds which we call oxidizing agents. It basically kills the cells. And this particular drug has these particular properties, 3 really interesting properties, which we think may be really, really exciting. And we've got some fantastic results in preclinical models, and the Curtin research team are in the process now of teeing up collaborative studies with colleagues at Royal Perth Hospital and Charlie Gardner Hospital, and we hope to be embarking on a clinical trial next year to trial this historic drug. Very different to any other drug which has been trialled in the Alzheimer's space, but we've got a strong body of evidence that this just might be something outside the box.
When it comes to our approach to helping people who have dementia or Alzheimer's in whatever stage of their life they're at, how's it going, and how's it changing?
Well, firstly, I've got to give credit to supporter organisations like the Alzheimer's Association and so forth. So they've really developed comprehensive frameworks to provide information and advice to both people who are in the process of developing the disease, and they provide an enormous amount of information to the carers of people who will go on to develop a dementia type of phenotype. I think it's a much more sympathetic consideration than perhaps it was several decades ago, which is a really good thing. And many people are, have been touched by someone in their family or they're very close to with the disease. Having said that, there is always a constant shortage of resources and facilities and the provision of, really good service centres to support people with significant cognitive challenges. People who develop the disease can, in a behavioural context, be very different. Some could be relatively happy in their space for a period of time. Others can really experience very emotional, high anxiety, depression-like syndromes, which is really very challenging for all concerned, including the participant. It was quite a few years ago now, but I was at a dementia conference once, and it was almost like an extended caravan where you had the opportunity to go in there and you were role modelled as the patient with Alzheimer's disease. And, you went into this caravan and they would sort of kit you up in a bit of a costume, and then the lights would go down and then the lights would come back on, and you'd find yourself at the edge of a bathroom environment, and there's this carer that's come in and they're sort of talking to you, and there's this voice audio that's going in the background saying, who is this person, what do they want, and stuff like that. And it was a really haunting experience just to try and get some sense of what it's like to be an individual with Alzheimer's disease or with a dementia condition. So what's really important, what's often afforded in the advice that's given to the caregivers is people who have got this, it's really important not to challenge them. It's really important to always be sympathetic in the position that they're in, to understand that their way of processing information or dialogue is very different to yours. So caregivers are told, be patient. Yes, you are going to get questions asked of you repeatedly and so forth. It's very much about trying to support the person with the disease in an environment which is not confrontational, which is really good. I might just say that there's some, very exciting models in Europe, and I can think of ones in the Netherlands where they actually have set up aged care centres focusing on people who have dementia phenotypes. And these are fully self-contained. They are secure environments. And essentially, people can get lost in this micro little village. So there's shops for them and hairdressing salons and so forth. And they have full-time live-in people who there. Some of them have got buddy kind of arrangements. So it could be people who don't have any close family member. You can have like a uni student can live with them and provide them some sort of support. So there's lots of new models being trialled, and can you provide a living environment which is non-confrontational for the person afflicted with the disease, whilst also providing them with support and so forth. There's, music therapies which are introduced. There's food therapies which are introduced. So there's many ways of providing allied health kind of services and support. So we're getting better. Still a long way to go, and, a lot of it depends on resourcing, doesn't it? But, it's improved. It's improved markedly.
You mentioned a little earlier around how some of the damage that could be causing these dementia conditions could be happening years before any obvious symptoms. In terms of what some of the listeners might be able to do now in terms of behaviours that might help mitigate their risk of developing dementia in the future, what are some of those things? Sort of, thinking exercise, mental training.
Yeah, look, I'll give some generic advice on that. So firstly, I think the simplest message is if you want to follow healthy living advice, which is given in the context of heart health, it's very likely to be good for brain health. So all the good things that we know that we should be eating, complex carbohydrates, not simple sugars, modest intake of saturated fats, that's the hard, chunky fats that you get on the outside of some of the meat products, not high processed meats. I think underrated is the critical importance of micronutrients. I wouldn't recommend that one ordinary go to a vitamin supplement, but the simple way of doing that is to, you get most of your micronutrients from fruits and vegetables. And the best way to adopt that, to make it simple on oneself, is to actually think of colours. So, you can think of your fruits and vegetables from the greens, the yellows, the whites, the blues, the purples, the whole kit and caboodle, and just ensure that you've got lots of colour continuously. And if you can't, I'm not saying it has to be done in one day, but over the course of the week, you should be capturing all those colours through all of those things. Keep your vegetables nice and raw. So keeping the saturated fats out. Be really mindful where saturated fats are kind of sneaking in. Like, if you have a nice roast, I love a roast, that's perfectly fine. But, if you've got to make some gravy, you're using the pan juices, and was it a lamb roast and did it have a lot of fat? Drain the fat off it. There's ways of doing that pretty simply. One of the things which is a real big concern for me is that we have a culture of drinking. It's all right to drink. It's okay to have a beer for this, or it's so-and-so's birthday. And if you put on...
also a culture of excessive drinking as well.
It is. Well, let me say, excessive drinking starts from the number one. There is no safe level of drinking alcohol. Fortunately, we're seeing that message now being articulated through media portals. So we have drinking which we say is tolerated and that's not unreasonable, but there is no level of safe alcohol consumption, nothing. So we know its risks with cancers and so forth. So we've got a culture around it, but we celebrate so much of what we do around drinking. I'll come to brain training and exercise stuff in just a moment. The one thing which, in terms of a food commodity, which people really underrate, and I think it's got a bit of bad press to it, unfortunately, is the potential value of full cream milk. Full cream milk is a food commodity, naturally occurring food commodity, which is packed with vitamins and minerals. It's an extraordinary source. But the other thing we know about milk, it's relatively low in fat. Even full cream, it's still only 4%, so that's not high fat. But there's some really interesting studies which have been coming out with milk. And we now know that the fats that are in milk are not just fat. Some of these fats have really potent bioactive properties. And the brain's actually a fat-rich organ. And there's aspects of full cream milk which are really good for vascular health and maybe very good for brain health as well. So if you're drinking, I think an adult, if they can drink, 400 to 600 mils of milk a day, I think that's a really good, simple thing to do. It's not going to cost you anything, and I guarantee it will not do you harm. And for those who are worried about their heart health, it's not going to do anything to blood cholesterol levels, nothing at all. So that's really good. The thing around brain training I find really, really interesting. I started off part of the podcast where I was talking about energy utilisation in the brain. And the way the brain utilises energy is it's got these little things inside the cells. They're called mitochondria. And all that is, it's a spark plug. It's what burns the sort of energy.
It's the powerhouse of the cell.
It is. That's exactly right. It's the powerhouse of the cell. And the brain cells have got more of these spark plugs than any other cell in the entire body. And when you look at people during their sleep behaviour and their sleep pattern, you can monitor the degree of energy utilisation they're doing in the brain, and when it's really active, those mitochondria are burning energy at the rate of knots. Now, occasionally, and during sleep, it's critically important that those cells rest, right? So if you did an MRI scan and you were looking at energy utilisation of someone when they're thinking or, the usage is just absolutely phenomenal. So think about when you get up in the morning, you've had your breakfast, you're driving into work, you've got the radio going, you're thinking about things that you have to do at work, you're watching where you're driving. Just think about the energy utilisation that's going on there. What's happened, because we've got electricity, so the lights can stay on at night. We've got all sorts of entertainment opportunities around TV and streaming and podcasts like this one and stuff like that. You've got the opportunity to keep your brain going non-stop, right? And if you're a person who's a bit under pressure and you come home and you're tired, so you might have a glass of wine, sit down and, I'll go to bed in a minute. And then if you're unfortunate, it's the cold time of the year. 2 a.m. Yep, it's 2 a.m. and, you get a cold. Well, what do people do? They take a cold and flu tablet and that just knocks it down. So what we've actually lost is the realisation that we need to rest the brain. Like, if you're running that marathon I was talking about, do you just go run another marathon if your leg muscles are tired? So when I liaise with people who are they feel they've got some memory challenges and so forth, part of my counselling that I provide them is, yes, around healthy eating and stuff like that, but part of it is also about ensuring that you reduce inputs. You've got to rest the brain sometimes. So important sleep. It's really important to get good sleeping habits behind, but you can do things to just take a bit of pressure off the brain. So when you're in the car, try keeping your radio off for a little bit. You don't have to go jogging all the time. Just go for a quiet, simple walk. If you can take a nap, if your body is cueing you to take a nap, it's telling you so for a reason. Follow your body's cues. So people who are exceedingly busy, have high executive function, they don't need to go do Sudoku. They probably need to rest the brain, and most people are sleep deprived. And many older age Australians have really bad sleeping patterns. There's a lot of people who have not full obstructive sleep apnea, but that's a big issue because you get periods of oxygen deprivation. There's things you can do around that. So yes, good food, good nutrition, no alcohol consumption ideally, but also, if you're not challenging yourself at all, by all means go do something, but give it a break as well.
Well, that's good news. I was worried I'd have to learn how to do the cryptic crossword.
No, but maybe tango.
Well, I guess that brings us to the end of our discussion. Our thanks to Professor John Mamo for sharing his expert knowledge on this topic.
Thanks very much.
You've been listening to The Future Of, a podcast powered by Curtin University. If you have any questions about today's topic, get in touch by following the links in our show notes. Bye for now.